Let's move to the next question. In this question, we have given a quadratic equation 1 plus ms square times n square x square plus 2mn cx plus c square minus a square, and it is having equal roots. We have to prove that c square is equal to a square times 1 plus m square. Let's work out the problem. If ax square bx plus c is equal to 0 is a quadratic equation, then the roots of this equation are x is equal to negative b plus or minus under root b square minus 4ac divided by 2a. If we take alpha and beta are two roots of this equation, then we have roots alpha is equal to negative b plus under root b square minus 4ac divided by 2a. Similarly, we have beta negative b negative under root b square minus 4ac divided by 2a. Here we have given the roots are equal, so alpha is equal to beta. When we have equal roots, we have equal roots when the quantity, that is under root b square minus 4ac. Here b square minus 4ac is called discriminant. So under root discriminant in both these roots is equal to 0. We have equal roots, that is negative b by 2a. If and only if b square minus 4ac is equal to 0. So by using this condition, we prove the given condition. Let's work out the problem. Now we rewrite the given equation, which is 1 plus m square times n square x square plus 2mn c x and c square minus a square. Let's get the values of a, b, c. Here a is the coefficient of x square. So we have value of a is the coefficient of x square, which is 1 plus m square times n square. Similarly, b is the coefficient of x. The coefficient of x here is 2mn c, and here c is a constant term. Constant term is c square minus a square. So let's apply the given condition, which is b square minus 4ac is equal to 0. Then we have 2mn c whole square minus 4 times 1 plus m square times n square times c square minus a square is equal to 0. Let us transpose whole this term towards right hand side. Then we have 4 times n square c square, and on transposing we have 4 times n square and the product of two binomials, which is 1 plus m square and another is c square minus a square. Here on left hand side and right hand side, 4n square get cancelled. We remain with m square c square. Let's distribute this. Here 1 is multiplied with the whole term, that is c square minus a square. Then we have c square minus a square. Then we have to multiply m square with the whole term, that is c square minus a square. Then we have m square times c square minus a square. By simplifying we get m square c square minus a square. By distributing m square inside the bracket, we have m square c square minus m square a square. On left hand side, right hand side, we have m square c square. So both get cancelled, and here we have negative terms, that is negative a square and negative m square a square. So we transpose to LHS. We have sum of a square and m square a square, which is equal to c square. So rearranging we get c square is equal to a square plus m square a square. Here we take m square common, then we have c square is equal to a square times 1 plus m square, which is the given condition we have to prove. Thus we have got the condition, which is c square is equal to a square times 1 plus m square, and this completes our solution. Let's move to the next question. In this question, we have given the sum of square of two consecutive odd positive integers is 220. Let's work out the problem. If we take the series of positive integers, that is 1, 2, 3, 4, 5, 6, 7, so on. Here 1, 3, 5, 7 are odd positive integers. If we take 1 and 3, these two are the two consecutive odd integers. Similarly, 3 and 5 are two consecutive odd integers, and 5 and 7 are two consecutive odd integers. That means the difference between two consecutive odd integers is 2. So we have to find out the two consecutive odd positive integers. So we assume n is any odd number. If we add 2 to this number, then the next consecutive odd number becomes n plus 2. Therefore we have n and n plus 2 are two consecutive odd positive integers. Here given that the sum of the square of two consecutive odd positive integers is 290. So we have n square plus n plus 2 whole square is equal to 290. By solving this equation for n, we get the value of n. Let's simplify this equation. Here we have n square. N plus 2 whole square is n square plus 4n plus 4, and it is equal to 290. Sum of n square and n square is 2n square. We have 4n. By subtracting 4 from 290, we have 286. In the next step, we divide both sides with 2. Here we have n square plus 2n, and on right hand side we have 143. By transposing 143 to left hand side, we have negative 143. Now we have to take the constant term, which is negative 143, and find out its factors. What are its factors? Here 143 is 11 times 13. Here we have negative sign, so we put negative 11 times 13. Similarly, negative 13 times 11 is also negative 143. So we have to take the factors in such a way that the sum of these factors is equal to coefficient of x. If we take negative 11 and 13, when we add them, we get the sum is equal to plus 2. So we take these factors, negative 11 and 13. We can write the equation n square plus 13n negative 11 and negative 143 is equal to 0. By taking n common from first two terms, we have n times n plus 13. Similarly, from the third and fourth term of this equation, we take negative 11 common. Then we have n plus 13. The whole sum is equal to 0. Let us take n plus 3 common. Then we have n plus 3. Then we remain with n and negative 11. So n minus 11. And it is equal to 0. Now the product of these two factors is equal when each factor is equal to 0. Then n plus 13 is equal to 0, or n minus 11 is equal to 0. Then we have the value of n is negative 3, or the value of n is 11. Since we are given in the question, here the odd numbers are positive integers. So we eliminate the negative value, that is negative 13. Then we have the value of n, and it is 11. So the next consecutive number which is odd is 13. So 11 and 13 are two consecutive odd positive integers whose sum of the squares is equal to 290. So 11 and 13 are two consecutive odd integers whose sum of the squares is 290. Let's move to the next question. In this question, if 12th term of an AP is negative 13 and the sum of its first 4 terms is 24, we have to find out the sum of its first 10 terms. In this question, we have given two conditions, which is 12th term is negative 13 and sum of first 4 terms of an AP is 24. According to these conditions, we have to find out the sum of first 10 terms. So let's work out the problem. In this problem, if we don't know the first term and common difference, we take first term A and common difference small d. If A is the first term and D is the common difference, then the nth term of an AP is A plus n minus 1 times D. Here we are given 12th term of an AP, then we have 12th term is equal to A plus 12 minus 1 times D, and it is equal to negative 13. Let's simplify this. A plus 11D is equal to negative 13. Here we have one equation. Let it be equation 1. Now here we are given sum of its first 4 terms, that is 24. If A is the first term and D is the common difference, then the sum of n terms of an AP is n upon 2 times 2A plus n minus 1 times D. Here we are given sum of first 4 terms. So sum of first 4 terms, that is S4, is 4 upon 2 times 2A plus, here n is 4, so 4 minus 1 times D, and the sum is equal to 24. So we have 24. Let's simplify this. Numerator and denominator contains the same factor 2, so 2 goes in for 2 times. Here we have 2 times 2A plus 3D, and it is equal to 24. On left hand side and right hand side, 2 is a common factor, so 2 goes in 24 12 times. So we have 2A plus 3D is equal to 12. Thus we frame another equation. Let this equation be equation 2. By using equation 1 and 2, we have to find first term and common difference. Now we have two equations. To get the value of A and D, we multiply equation 1 with 2. 2 times equation 1 is 2A plus 22 times D, and on RHS we have negative 13, so 2 times negative 13 is negative 26. So here when we subtract equation 2 from 2 times equation 1, we get the value of D. So here we subtracting equation 2 from 2 times equation 1. Now we subtract these equations by vertical column method. Here the equation which is to be subtracted, we have to change its signs. So plus 2A becomes minus 2A, plus 3D becomes minus 3D, plus 12 becomes minus 12. So plus 2A and minus 2A are cancelled out. 22D minus 3D is 19D, and the sum of negative 26 and negative 12 is negative 38. So here we have 19 times D is equal to negative 38. By dividing both sides with coefficient of D, which is 19, we get the value of D is negative 2. Therefore the common difference of this AP is negative 2, and we have A plus 11D is equal to negative 13. So by substituting the value of D in this equation, we get the value of A. So let's solve it for A. Here we have A and D is negative 2. A plus 11 times negative 2 is negative 22, and on RHS we have negative 13. By transposing negative 22 to RHS, we have A is equal to negative 13 plus 22. The sum of negative 13 and 22 is 9. So here we have the first term A is 9. Then we have the first term A is 9 and D is negative 2. We have to find out the sum of its first 10 terms, that is the value of S10. And here we have the sum of n terms of an AP is n upon 2 times 2A plus n minus 1 times D. Here we have to find S10. So S10 is equal to 10 upon 2 times 2A. Here A is 9. And then we have n minus 1 times D. N is 10. 10 minus 1 times negative 2. The value of D is negative 2. Let's simplify it. 2 goes in 10 5 times. And here we have 2 times 9, which is 18. And then 10 minus 1 is 9. And 9 times negative 2. 5 times 18 plus of minus 2 is minus. And 9 times 2 is 18. So plus 18 and minus 18 get cancelled. We remain 0. So 0 times 5 is 0. So the sum of first 10 terms is 0. And this completes our solution. Let's move to the next question. In this question, a fire in a building P is reported on a telephone to two fire stations, Station A and Station B, and they are 50 kilometers apart from each other on a street road. A observes that the fire is at an angle of 60 degrees to the road, and B observes that the fire is at an angle of 30 degrees to the road. We have to find out the distance traveled by the team of fire station A and the distance traveled by the team of fire station B. From this, we have to say which station should send its team to control the fire and what type of moral we learn from this problem. First of all, to solve these kinds of problems, we have to first draw a simple diagram to represent the problem. Let's work out this problem. Here we assume OP be a building and the two fire stations are A and B. Given that the distance between two fire stations is 50 kilometers, initially we don't know which station is nearer to the building or which station is far away from the building. So we move for further information. Here we are given A observes that the fire is at an angle of 60 degrees to the road. So the angle of elevation of A is 60 degrees. And we are also given B observes that the fire is at an angle of 30 degrees to the road. So this angle is equal to 30 degrees. As angle of elevation of observer A 60 degrees is greater than angle of elevation of observer B, which is 30 degrees, we can say that the observer A is nearer to the building. It is because both the stations A and B observing the same fire, so smaller is the angle, larger is the horizontal distance of separation. Since the angle of elevation of observer B is 30 degrees, so it should be at a greater distance from the height of the building. Let the horizontal distance of station A from the building be x kilometers, then the horizontal distance of station B from the building becomes 50 minus x kilometers. So here we have to find out the value of AP and BP since it is the distance traveled by the team of station A and B. To find these values, we have to find the value of x initially. So we have two right angle triangles. By using these, we find the value of x. Let's note down the given data. Now consider triangle POA. Here OP is perpendicular and OA is base, and we have the angle 60 degrees. So we consider tan. Tan of 60 degrees is the ratio of perpendicular to its base, that is OP upon OA. Here OP is unknown, it is height of building, and OA is the horizontal distance which we assume is x. Tan of 60 degrees is √3, and here we have OP upon x. By transposing x, we have the height of building which is x times √3. Now we consider triangle POB and substitute the value of height of building which is OP and get the value of. Here tan of 30 degrees is the ratio of perpendicular to its base, that is OP upon OB. Here tan of 30 degrees is 1 upon √3, and we have already got the value of OP which is x times √3, and OB is 50 minus x. So let's solve this for x. By cross multiplication, we have 50 minus x is equal to x times √3 times √3, that is x times 3. On rearranging, we have 3x is equal to 50 minus x. Let us transpose this negative x to left hand side. Then we have 3x plus x which is 4x, and it is equal to 50. By dividing with 4 on both sides, we get the value of x which is 50 upon 4, and it is equal to 12.5 kilometers. Thus we have got the value of x which is 12.5 kilometers. Here we have to find out the distance traveled by the team of fire station A. That is, to prevent the fire or to halt the fire, the distance traveled by station A is AP. So we have to find out the distance AP. Here we have got the value of OP, that is height of the building, and OA. By using this, we have to find out AP. So which trigonometric ratio we have to use? Here we have to consider either cos or sine. So we consider sine. Sine of 60 degrees is the ratio of perpendicular to the hypotenuse of right angle triangle, that is OP upon AP. Here we have to find the value of AP. We know that sine 60 degrees is root 3 upon 2, and we got the value of OP, which is x times root 3. AP is unknown. On both sides, root 3 get cancelled. By cross multiplication, we get AP is equal to 2 times x. That is, AP is equal to 2 times 12.5 kilometers, and it is equal to 25 kilometers. Similarly, we have to find the distance travelled by the team of fire station B, that is BP. Now to find the distance BP, consider triangle POB. Here we have OP and BP. So which trigonometric ratio we have to use? It should be sine, because sine is the ratio which gives the relationship between perpendicular and hypotenuse. So sine of 30 degrees is the ratio of perpendicular, which is OP, to hypotenuse, which is BP. Sine of 30 degrees is 1 upon 2. We have got the value of OP, which is x times root 3, and we have to find BP. So by transposing BP to left hand side, we get BP is equal to x times root 3, and we transpose 2 to right hand side. It is equal to 2 times x times root 3, which is 2x times root 3. Let's substitute the values of x. We have 2 times 12.5 times root 3. That is 2 times 12.5 is 25. So we have 25 times root 3 kilometers. The distance travelled by the team of fire station B is 25 times root 3. As the distance travelled by station A, that is AP, is less than distance travelled by station B, so station A should send its team to halt the fire. From this story, we have learned that there is a cooperation between station A and station B, and the responsibility of station A to halt the fire as early as possible. So this moral we get from this problem. Let's move to the next question. In this question, we have given points A x comma y, B a comma 0, C 0 comma b, and they are collinear. We have to prove x upon A plus y upon b is equal to 1. So let's work out the problem. Given points are A x comma y, B a comma 0, and C 0 comma b. Here A, B, C are collinear. So when do we say 3 points are collinear? 3 points are said to be collinear when they lie on the same line. Here we have A, B, C, and these 3 points lie on a same line. So we say A, B, C are collinear. By using this, we have to prove the given condition. So what happens when 3 points are collinear? When 3 points are collinear, the area of the triangle formed by joining these 3 vertices is 0. So we equate the area of the triangle ABC to 0, and then we get this condition. So first of all, we should know how we find the area of triangle whose vertices are given. If A x1 comma y1, B x2 comma y2, C x3 comma y3 are the 3 vertices of a triangle, then the area of the triangle is half of x1 times y2 minus y3, and x2 times y3 minus y1, and x3 times y1 minus y2. So here we denote x1 y1 is x comma y, and x2 y2 a comma 0, and x3 y3 b comma 0. So here we denote x1 y1 as xy, x2 y2 a comma 0, x3 comma y3 0 comma b. So let's equate the area of the triangle ABC to 0. Here we have area half of x1. x1 is x times y2 minus y3. Here y2 is 0 and y3 is b. So we have y2 minus y3. Similarly, x2 is a and y3 minus y1. Here y3 is b and y1 is y. So b minus y. And then we have x3 times. x3 is 0. So 0 times y1 minus y2. y1 is y. y2 is 0. So let's solve it. And the area is 0. So by sending half to right hand side we get 0. Then we have x times negative b plus a times b minus y. 0 times anything is 0. X times negative b is negative bx. Similarly, we distribute a inside the bracket. We have a times b, and here we have negative sign, so a times y. Let's distribute negative bx and negative ay to RHS. Then we have ab is equal to ay plus bx. By rearranging, we get bx plus ay is equal to ab. If you look at the condition, on RHS we have 1. So to get 1, we divide both sides with the product of AB. Then we have bx plus ay divided by AB, and on RHS AB divided by AB. Then we get the condition bx upon AB plus ay upon AB, and on RHS we have 1, and here numerator b and denominator b cancelled out. Here also numerator a and denominator a cancelled out. We remain with x upon a plus y upon b is equal to 1. So this completes our solution. Let's move to the next question. In this question, we have to find the ratio in which y-axis divides the line segment joining the points -4, -6 and 10, 12, and we have to find out the coordinates of point of division. Let's work out the problem. Here we denote the given points A -4, 6. Here we denote the given points A -4, -6 and B 10, 12. So here we have points A and B. According to the question, we have to find out the ratio in which y-axis divides the join of AB. And here we assume P be any point whose coordinates are x, y and it is lying on y-axis, and it divided the join of AB in the ratio k:1. And then by section formula we find the value of k. Let's proceed. And here we have the section formula, and the coordinates of a point which divides the join of any points x1, y1 and x2, y2 in the ratio k:1 is kx2 plus x1 divided by k plus 1. Similarly, y coordinates is ky2 plus y1 divided by k plus 1. So let's use this section formula to find the coordinates of point of division P. Here we have x coordinate of P, which is x, and we have the ratio k:1. So k times x2. Here we denote x1, y1 is -4, -6 and x2, y2 is 10, 12. So x2 is 10. So 10 k times 10 plus x1. Here x1 is -4. So plus of -4 divided by k plus 1. Similarly, we have y coordinate, which is small y, and it is equal to k times y2, k times 12 plus y1. Here we have y1 -6 divided by k plus 1. Since the point P is lying on y-axis, its x-coordinate must be 0. So we equate its x-coordinate to 0 and find the value of k. So we equate x-coordinate to 0. Then we have k times 10 plus of -4 is -4, which is equal to 0. K times 10 is equal to 4. By dividing with 10 on both sides, we get the value of k, which is 4 upon 10. Here numerator and denominator contains the common factor 2. So we have 2 upon 5. The required ratio is 2 upon 5. So by substituting the value of k in these coordinates, we get the value of point of division. We already know the y coordinate. We already know the x coordinate, which is 0, and we have to find y coordinate. So then we have y coordinate, and it is equal to k times 12. 2 upon 5 times 12 plus of minus 6 is minus 6 divided by k plus 1, which is 2 upon 5 plus 1. Let's simplify it here. Here y is equal to, here we have LCM is 5. So 2 times 12 minus 6 times 5. On denominator we have LCM 5. On numerator we have 2 plus 5, which is 7. By cancelling we get 2 times 12, which is 24, minus 6 times 5 is 30, and 2 plus 5 is 7. And here 24 minus 30 is negative 6 divided by 7. So the point of intersection, that is point of division, is 0, negative 6, 7. And this completes our solution.